find the solutions to the following trigonometric equations where theta is between 0 and 2 pi, not including 2 pi. And the first thing here on this problem is we have a quadratic thing. We have a squared term in it. So we're going to have to probably factor this problem. So as we start this out, let's subtract cosine of theta on both sides. And we get cosine squared theta minus cosine of theta equals 0. And the method of factoring that we're going to use on this particular problem is the greatest common factor. So we're going to factor it out. We're going to factor out a cosine of theta. And when we factor out that cosine of theta, we're left with cosine of theta minus 1 equals 0. I'm going to set each of these now that we have this in factored form, we're going to set cosine of theta equal to 0 and cosine of theta minus 1 equal to 0. And we're going to solve. Well, where does cosine of theta equal 0? It equals 0 at pi over 2 and at 3 pi over 2. So for here, a little bit more work. We add 1 to both sides. We get cosine of theta equals 1. And where does cosine of theta equal 1? Well, based on our restriction here, which I want to point out again, 0 less than or equal to theta less than 2 pi, it's just going to be at 0. It's true, cosine of 2 pi does equal 1, but it's not part of our restriction on theta. So it's pi over 2, 3 pi over 2, and 0. Problem number 2, the nice part of this one is it's already factored for us. So when we go to work with this particular problem, we're going to take tangent of theta, and we set it equal to 0, and sine theta plus 1, and set it equal to 0. And then we have to think back, well, where does tangent equal 0? And tangent equals 0, so theta equals tangent of 0 equals 0, but also tangent of pi equals 0. Solving this part of the equation, we get sine of theta equals negative 1. Well, where does sine of theta equal negative 1? That's going to be at 3 pi over 2. Flipping the page. Again, going back to our factoring on this particular problem. And what we need to do we're going to use the difference between two squares to factor. And square root of 4 is 2. Square root of cosine squared is cosine. Sorry, it's cosine theta. And the square root of 1 is 1. Difference between two squares, different signs. And we're going to set each of our factors equal to 0. So it's 2 cosine of theta minus 1 equals 0. And 2 cosine of theta plus 1 equals 0. And we're going to add 1 to both sides. So we get 2 cosine of theta equals 1. Divide both sides by 2. And we end up with the fact that cosine of theta equals 1/2. And then we ask ourselves, well, where does cosine of theta equal 1/2? Well, we're in the first quadrant, which is going to be pi over 3. And we're going to be in the fourth quadrant, which is 5 pi over 3. And hopefully you don't have to go back and do the math. I'm going to do it, but subtracting 1 from both sides, we get 2 cosine of theta equals negative 1. divide both sides by 2, and we get cosine of theta equals negative 1/2. And then we need our other pi over 3 angles here in the second quadrant, so 2 pi over 3. And in the third quadrant, it would be 4 pi over 3. On problem number 4, we need to use one of our identities to solve this. And I'm going to flip the page here for a minute, and then I'll come back to this one, because here are the identities. And let's just take a look at these and fill them in. Sine of theta is 1 divided by cosecant of theta. Cosine of theta is, how about I write this correct? 1 divided by secant of theta. Tangent of theta is 1 divided by cotangent of theta. And then the other direction here, cosecant is 1 divided by sine. And secant is 1 divided by cosine. And cotangent is 1 divided by tangent. Tangent is sine divided by cosine. And since cotangent is the reciprocal of tangent, this is going to be cosine divided by sine. And we can come back and, no, I'll just go ahead and fill these in here. But the main identity of which you can define, you can figure out all of the other functions from, the main identity is the fact that sine squared theta plus cosine squared theta equals 1. And we're going to come back to this. This one is going to help us solve that previous problem here momentarily. But we can rewrite this now. We can say that sine squared theta equals 1 minus cosine squared theta, or cosine squared theta equals 1 minus sine squared theta. To figure out the next identity here, we can take our main identity of sine squared theta plus cosine squared theta equals 1. Actually, I'm going to scoot this over. But let's divide everything in this function by sine squared. And when we do, sine squared divided by sine is 1. Cosine squared divided by sine squared is cotangent squared. And 1 divided by sine squared is cosecant squared. And I'm going to switch up the color here on this one, but our next one is going to be 1 plus cotangent squared theta equals cosecant squared theta. And we move these things around to fill in the rest. So we can say 1 equals cosecant squared theta minus cotangent squared theta. Or we can say that cotangent squared theta equals cosecant squared theta minus 1. And I don't know why I didn't change colors on that one, but anyway, they are still good here. So let's take our sine squared theta plus cosine squared theta equals 1, and let's come up with the last set of our Pythagorean identities. And we divided, and that pickish purple, by sine, so let's this time divide everything by cosine squared. So when we divide everything, sine squared divided by cosine squared is tangent squared theta. Cosine squared divided by cosine squared is 1. And 1 over cosine squared is secant squared theta. And that's going to be our primary here in this third column. Tangent squared theta plus 1 equals secant squared theta. And then we can move these around a little bit. If we move this around, we can say that tangent squared theta equals secant squared theta minus 1, subtracting 1 from both sides. Or we can also say, and I should have done that one first, but we can also say that 1 equals secant squared theta minus tangent squared theta. Now, I write all those down. Again, we need to go back and do that previous problem. And what we're going to be using here is, far left, the sine squared equals 1 minus cosine squared. That identity. So sine squared equals 1 minus cosine squared theta plus cosine of theta equals negative 1. Well, then what's going to happen is we're going to simplify here. So let's move the 1 over, and let's put it in order. So this is negative cosine squared theta plus cosine of theta plus 2 equals 0. And by the way, let's move that to the other side so that we don't have a negative cosine squared. So we're going to take the negative cosine squared and we're going to move it over here to the right. So it's going to become positive cosine squared. So it's going to be 0 equals. And then we're going to move the cosine over, so that's going to be minus cosine theta. And then plus 2 is going to be minus 2 when we move that over to the other side. And now we're going to factor. And it depends on your teacher, but your teacher might have used let u equals cosine of theta when you factor. But ultimately what happens when we do factor in this particular problem is we end up with a cosine theta and a cosine theta, and then a 2 and a 1, and it's going to be minus 2 and plus 1. So we factored, and now we need to take each factor and we're going to set that equal to 0. So cosine of theta minus 2 equals 0. And cosine of theta plus 1 equals 0. I'm going to add 2 both sides. We get cosine of theta equals 2. The thing is, where does cosine of theta equal 2? We never get to. So this one, you might write no solution, or you might cross it out. Over here, if we subtract 1 from both sides, we get cosine of theta equals negative 1, and we do have values where cosine of theta equals negative 1. In fact, we only have one value, but where we solve our equation now is that theta equals pi.